Good morning, it's me, Mr. Trewin, and we're back again for another installment of geometry lessons. Today's little lesson is about something called the triangle angle sum theorem. And basically what it says is that the sum of the three interior angles is 180 degrees. So when we look at a triangle, we have three sides on a triangle and we have three angles inside, and those three angles have to add up to 180 degrees. So when we add up the measures every time, each one, as we add them together, we should always be thinking at the end, this has got to total 180 if it's going to make a triangle. The one after that, or the one below it here, is called the triangle exterior angle theorem. And this tells us that the measure of one exterior angle is the sum of the two remote interior. And they're called remote interior because here's the exterior angle A, and this would be its linear pair. Well, B and C are called remote angles, and if you think about remote, like meaning afar, B and C are kind of the farther away angles from A, and they just don't make the linear pair with A, so we call them remote interior angles. That's my best explanation to make it simple, but I like to think of remote as far away, so here's A and B and C are far away. Just trying to keep it simple, something that you can remember. All right, and the rule is this: the angle on the outside has got to be equal to the sum of these two. So if you add these two angles up, and I should have little degree symbols, we know that if we add up the two angles on the inside, they should equal the one on the outside, provided they're the two remote angles. All right, so I've got 4 examples laid out here, and I'm going to kind of go through each one, and we're going to use these 2 rules, and then we have an assignment that we're going to work on later today. But right now, let's look at the 2 rules, and then let's apply them. So I'm going to use example number 1, and I'm going to have a calculator handy, because we're not going to make any mistakes with our calculations. We're going to double check since we're allowed to use calculators. Let's do this. All right, so in this one, I'm trying to figure out 2 different variables, x and y. And I have to figure out which one would be, because I see 2 triangles, I have a triangle on the left and a triangle on the right, I need to figure out which one is going to be easiest or where I should begin to work this problem. So if I take a look on the left, I can see that I have a 77 degrees and I have y degrees. So I don't really have anything here, and I'm missing this, so really I'm missing 2 numbers, and I don't think I can do much with that because I'm missing 2 of the numbers. I can figure out a triangle, I can figure out a missing number if I'm just missing 1, but in this case I'm missing 2. So I'm going to have to look at the other triangle and see if I can work from there. So when I go over here on this side, I have x degrees, 96 degrees, and 35. Well, what do I know about these 3 things is according to the triangle angle sum, they should total 180 degrees. So let's start by writing that down and see if we can figure that out. I have x, the unknown. I have 96, 35, and I know this has to total 180, so 180. Well, let's collect our like terms. I got a 96, so 96 plus 35, that gives me x plus 131 degrees equals 180. All right, well, let's see. Subtract 131 from both sides, and I believe our answer will be 49 degrees. Now, one thing we always got to do in these problems is every time we do that, we need to always plug in information. So right away, I know that x's are now 49 degrees. And although this is really good, and I've answered half the problem, I'm still in the jam with how do I figure out y? Because I have only 2 things to work with, and one of them is a variable. Well, when I say that, that's not exactly true, because if we think back to chapter 1, we did learn a little bit about something called a linear pair. And that means that this 96 and this missing angle right here, because they make a straight line, they make a linear pair, they should be adding up to 180. So maybe I should do that off to the side. Let's see, I'm gonna have to give this a variable because I need this number to give this one. So I'm gonna give this a W for what? What happened here? So W plus 96 equals 180. Well, let's minus that 96. So 180 minus 96 tells me that this one right here, W, was equal to 84. All right, well now I have something I can work with, because now how many measures do I have? 2. And I just got to figure out the third one. So I'm going to use the same ideology here. I'm going to go with the triangle angle sum, and I'm going to say, well, 77, or y plus 77 plus 84 has to all equal 180. So adding them together now, I got 77 plus 84, that's 161. And I got to take that away from 180. So minus the 161 gives me y is equal to 19 degrees. So one thing I'm going to encourage you to do is, as you do these problems, always think, just because there's not a variable there, doesn't mean I don't need to figure it out. Sometimes that's the only way you're going to get to the end of the problem, is if you figure out maybe something like that missing number. It's kind of like where you might feel like you're getting tricked a little bit, because you're like, you only wanted me to find 2 variables, but I had to find 3 to get the answer. Just kind of keep that in mind. All right, our next example number 2. All right, let's look at example number 2. And I got to, again, go down to that decision. Where am I going to start? On the left side, I have a y and a 42 and a blank spot. On the right side, I have an x, a 57, and a 59. Well, again, I'm going to go back to the triangle angle sum, which tells me these 3 items should add up to 180, and I know 2 of them. So by doing a little subtraction, I can find the third. So I'm going to do that. And I'm going to write on the paper, I'm going to write 57 plus 59 and plus x all equals 180. I add my pieces together, so 57, 59 gives me 116. Oops. Well, if I do a little subtraction, minus that 116, I get x's are equal to 64. All right, so let's plug that in. Now I know one variable's down, and I got to figure out the other one. But again, I'm still stuck because I got a y and a 42 and a blank spot. Or do I? What was the rule we learned in chapter 1 about these kind of angles? When 2 lines intersect, they form something called vertical angles. So if this one on the right is 64, I can go ahead and just pencil this in as 64 as well, because I know the 2 of them have to be equal and congruent because they're vertical angles, which puts me right back in the same place over here. I've got a variable and I've got 2 measures. I can find that variable very quickly. So I'm going to just go y plus 42 plus 64 equals 180. So total them up. 42 plus 64 plus 64 equals 106. And I'm always going to check my math in the morning because it is early. It is just after 6 in the morning, and I make mistakes every morning. So I'm going to go ahead and write my work down and use a calculator. And I'm always going to encourage you to use a calculator. It comes out to be 74 degrees. So there we go. But you have to constantly think about this in this class, is that sometimes you're going to have to work things out that aren't specifically asked for, but are required to get to the end of the problem. All right, so let's look at these last 2. These are an example of the triangle exterior angle theorem. And the rule here is this. I know that this one right here, 104 degrees, should be equal to x and 49. Because that's the way it works on this theorem, is that the exterior angle equals the sum of the remote interiors. And since this one is 104 and it's on the outside, and this is its linear pair, the remote angles are these 2. So let's put that into an equation, and I'll write it out. We'll say, I know that 104, according to the rule, 104 has to equal x plus 49. Well, if I take 49 from both sides, I should have the answer. So 104 minus 49, and that gives me 55. Now, if I plug that in, there is a way to check my work. Because what I can do in this case is I can always go back to the triangle angle sum theorem and say, well, I know that triangles have to make 180, and I think this is 55. I can double check that because I know that this one over here called 104 and the angle right next to it, they're a linear pair, which means together they make 180. So if this is, for example, 104, that means on the other side of that, to make that linear pair is 76, because 76 and 104 make 180. Well, let's just double check our work then. Because if we did this correct, 76, 49, and 55 should make 180. So let's try it out. So 76 plus 49 plus 55 equals 180. It's a winner. We got it right. But we can double check because we can use this one to double check our work for this one. And remember, we're constantly, for this class, we're always going to be going back to previous lessons. We're going to have to go back to chapter 1. That's the only way that we were going to be able to solve this one is if we went back to what was a linear pair. And the only way I was able to solve this one was to use a vertical angle. So just remember, we're constantly referencing previous chapters. Just because we're in chapter 2 does not mean you're confined to only using things from chapter 2. Everything that we learned in the beginning is fair game, and we're going to use it all the time. Okay, last one. If I had to work this problem out, I got a couple ways to do this. I'm trying to figure out x and y, and the rule is that, for example, x is a remote interior angle. X should be the sum of 48 and 77. So let's see what happens there. X is equal to 48 plus 77. All right, so let's see, 48 plus 77 gives me 125. And I can go back to chapter 1 and double check that work because right here I see 125 and 55 is a linear pair. They're right next to each other, you see, and they form a straight line. That means that they should add up to 180. And I can double check that by just simply going 55 plus 125, and yep, it's 180. I can double check if I had gone with y. Y is a remote exterior angle. It's just upside down. You'd have to flip your paper up there to see that, but you notice that it is also the same one. And that's why, if 125 is here, what do we know about this? Intersecting lines, pulling a vertical angle right there, and that's 125 degrees. All right, so this just kind of sums it up, and these are just two rules we're going to use a lot of. We're going to use this for pretty much the rest of the school year, but don't forget, we're always going to be referencing chapter 1 as too, material as well. All right, good luck, get this done, and have a great day. Bye.